Bismillahirrahmanirrahim. Students, now we are going to discuss uh, linear inequalities and linear programming, a words problem, daily life example, and I am going to discuss question number 7, 8, and 9. So, we start with linear inequalities. Now, inequalities are expressed by the following four symbols. The first one is greater than. You can see this sign represent greater than, or in linear equation you can present this as generally ax plus by is greater than c. Second one is less than, and you can represent this by ax plus by is less than c. Third one is greater than or equal to, and you can represent in a linear equation like this: ax plus by is greater than equal to c. And lastly, we have less than or equal to sign, and you can present this as ax plus by is less than c, where all a, b, c's are constant, x and y are variables. Okay. So next we move on to shaded region. A very important point, how to shade the required region. So I have a very simple rule related to shaded region. For example, if you have a horizontal line and if you have a sign greater than equal to, then just shade above this horizontal line. If you have a less than equal to sign, you shade less than below this horizontal line. If you have a line, vertical line, and the sign is greater than equal to, you should shade right hand side of that line. If you have a symbol less than equal to, then you should shade less than or left hand side of this vertical line. And if the lines are diagonal like this, then in case of greater than equal to, shade the above region. In case of less than equal to, shade the below region. Similarly, in this diagonal line, you always shade greater than equal to above area and less than equal to for lower area. So very simple, four lines or four rule to shade a region. But you have to note that you must always make coefficient of y positive in order to follow these rules. Now, what is coefficient of y? I will give you one or two example to explain this, that you should have coefficient of y positive in order to maintain, in order to follow these rule. But a very simple rule. So I start with a simple example, that is, you just have to draw this inequality and shade the region. And the question is x plus y is less than equal to 1. First, this convert this inequality into associated equation or corresponding equation. Mean just replaces this less than equal to sign by equal to sign. Okay, then make a table for a graph. Mean just put x is equal to 0 in this equation 1. We have y is equal to 1. So complete this table. When we put x is equal to 0, we have y is equal to 1. And another one is put y is equal to 0, then we have value x is equal to what? X is equal to 1. So in order to draw a straight line graph, you can take only 2 points. Mean first one replace x by 0 and second one replace y by 0. You just have to complete this table, this small tiny table, in order to make your lines. Then the very important point is when we are drawing a graph is scale. Mean on x-axis in this question, one small square is equal to 1 unit, and on y-axis suppose one small square is equal to 1 unit. So draw a graph paper. This is your x-axis, positive, negative. This is your y-axis, positive, negative. You can see that one small square on x-axis and on y-axis is equal to 1 unit in positive, negative x-axis. Now draw these points. First we have x is equal to 0 and y is equal to 1. Mean we have order pair 0 and 1. Mean x is equal to 0 is that origin, and y is equal to 1 where? This one. So draw a small circle. And then we have x is equal to 1 and y is equal to 0. So x is equal to 1 we have here, x is equal to 1, and on x-axis all the values of y are 0. So join these 2 points by a straight line, which is actually a graph of that straight line, which is x plus y is less than equal to 1, sorry. In order to in order to shade the region x plus y is less than 1, just remind the 4 line and the point that coefficient of y should be positive. Here we have coefficient of y is plus 1. If coefficient of y is positive, then follow the simple rule. Mean if less than equal to, then draw a region less than equal to given line. So we have this area which is our required region. Just make some arrows to indicate this, or just shade this to represent our required region. Okay, so this is the first example, and now I am going to discuss a very similar example, and the difference is x plus y, x minus y is less than 1. So you have to draw the graph of this and explain this or find the shaded area. First, you have to convert this into associated equation or corresponding equation. Mean just replace this less than equal to sign by equal to. Then what? Put x is equal to 0 in this equation 1. We have y is equal to minus 1. Put y is equal to 0 in this equation 1, we have 1. So make that table and draw the line. You can write it as, just to best presentation, write it like this: put y is equal to 0 in equation 1 and put x is equal to 0 in equation 1. In order to make the graph, you should define your scale. On x-axis, one small square is equal to 1 unit, and y-axis, one small square is equal to 1 unit. This is your positive x-axis, negative x-axis, and your first order pair is 0 and negative 1. X is equal to 0 at origin and y is equal to negative 1 here. So make a circle. Then x is equal to 1 and y is equal to 0. Here x is equal to 1 and y is equal to 0. Make a circle. Then join these two circle with a line which is a line x minus y is equal to 1. In order to shade the region, again just remember the rule. The coefficient of y should be positive, but here we have coefficient of y negative. In order to make it positive, we multiply this equation inequality by negative. When we multiply an inequality with negative, less than equal to sign becomes greater than equal to, and greater than equal to sign becomes less than. Mean this less than sign becomes greater than equal to in order to make that coefficient y. It means you have to convert this less than equal to greater than equal to, and your required line is, your required shaded area is above the line. It reverse this negative sign, this reverse this less than sign into greater than sign. So you should shade above the area. All the area is the required region. Hopefully you understand this. Actually, it's a very important point how to shade the region. Okay, so next coming back to our main point. Okay, a very important two notes. If you have to shade y is greater than equal to 0, then what will happen? Y is greater than equal to 0 mean you are talking about x-axis where all the values are y are 0. So you are talking about x-axis and the graph is the upper half plane including the graph of the corresponding line. Y is equal to 0 mean x-axis, and you can see the graph on your screen. That is, this is your x-axis, red line represent this, and positive mean greater than or greater than mean above the line. Just remember the rules, 4-line rule. Above the line and your shaded required shaded area is above that horizontal line. So this is the first important point, first note you can say that. Another note is when x is greater than equal to 0, then what will happen? Okay, if you have to shade this region, mean you are talking about y-axis, and y-axis all the values of x are 0. In this case, actually you are talking about y-axis and the positive sign or greater than, and this is your y-axis, and greater than sign or positive, right hand side is positive. So your required area is this. No need to make fishes. It's just a beautiful presentation. So just follow a simple shading region. Okay, four rules and two notes, and then I am going to forward what is objective function. In order to solve the word problem related to linear inequalities, we have to set an objective function. A function which is to be maximized or minimized is called objective function. Okay. Then the second one is feasible solution. Feasible solution, a solution which lies in first quadrant. The feasible solution which maximize or minimize the given objective function is called optimal solution. So these are two or three definitions which I am going to use in word problems. So you should know what is objective function, what is optimal solution, and what is feasible solution. Okay, and what is theorem of linear programming? It states that the maximum and minimum value of the objective function occurs at corner points of the feasible region. Now what is theorem of linear programming? I am going to discuss in 3 points what is this in my next slide. So procedure for determining optimal solution. You just have first graph the solution set of linear inequality constraints to be determined to the feasible region. So first step is to make a feasible region. Second step is to find the corner points or vertex of that feasible region. And the last point is evaluate the given objective function at each corner point to find the optimal solution, whether it is maximum or minimum. So these are the 3 points which is I'm going to focus on our next word problem. Okay, so now we start our word problem and follow these 3 rules: feasible region, corner points, and objective function. So first we have to convert this word problem into linear inequalities in order to find optimal solution. So you can see question is each unit of food x costs 25. We have two types of food. Unit x costs 25 containing 2 units of protein and 4 units of iron. Okay, and then 2 units of protein and 4 units of iron. Okay, and then you have a food y which costs 30 rupees per unit and containing 3 units of protein and 2 units of iron. Okay, so we have two types of food, food x and food y. Next, Each animal must receive at least 12 units of protein. So we have a restriction that we have at least 12 units, mean minimum of 12 units. You can take 13, 14, up to so on according to our requirement. So at least you can take at least 12 units of protein and 16 units of iron. And how many, you have to find how many units of each food should be fed to each element at the smallest possible cost. Mean your main objective function is to minimize the given objective function. Now I am going to convert this whole statement into a picture. And what is mean, you have two type of food. Kindly just follow the color scheme, the color language which I am going to use in this lecture. We have a food, two types of food, X and Y. And the next one is price of each unit of food X is rupees 25. You can see on your first line, price of each unit food X is 25. And in X food, you have protein 2 units and iron 4 units. And in Y, cost of each unit of price food Y is 30 rupees. And you can use 3 units of protein and 2 units of iron. Another condition, you should use 12 units of protein, mean at least you can use 12 units of protein and 16 units of iron. So I just convert this word problem into this picture form. Now I suppose X unit represent food X and Y units represent food Y. And first aim is to make objective function. So what is your objective function? You have to minimize smallest possible cost, minimize f of xy 25. You can see that food X represents small x, 25 rupees, 25 into X and 30 into Y, subject to the constant. And we have a constant and just build to this these constant. First you have to focus on purple color. You can use 2 units of protein, mean 2x. You can use 3 protein. You multiply this y, and at least you can use 12 protein. So you can see that 2x plus 3y is greater than 12. Just follow the color scheme. And what will be the next constant? You can focus on red side. 4 units mean 4x plus 2 units of iron 2y, and at least mean less greater than equal to 16. So our next constant is 4x plus 2y is greater than equal to 16. And lastly and most importantly, x must be greater than equal to 0 and y must be greater than equal to 0 in order to make this animal feed. Okay, so this is very a simple way to convert this word problem into linear inequalities. Now in next slide I am going to solve these inequalities. Okay. So far we have a function which is minimized. We have to check minimum of 25 of x, 35, and these constants. Just solve these constants. First take 3x plus 2x plus 3y is greater than 12. Just first convert this into associated equation or corresponding equation. You can say this is your equation number 1. In order to make a graph, we must build a table, mean put x is equal to 0 in this equation 1. We have y is equal to 4. Then replace x is equal to then equation 1. We have y is equal to equation 1. We have x is equal to 6. So just make a table by switching by just finding two values, either x is equal to 0 or y is equal to 0. Okay, make a scale. On x-axis, 1 square box is equal to 1 unit, and y-axis, 1 square box is equal to 1 unit. Make a graph paper. This is your x-axis, y-axis. You can see your scale. and the first point is 0 and 4, and the next point is 6 and 0. So first 0 and 4, x is equal to 0 here and y is equal to 4. You can see a circle at point 4, and then x is equal to 6. You can see that on this point and on x-axis all values of y are 0. Just join these 2 points, you have your line. Just write the name of this inequality, which is 2x plus 3y is greater than 12. Now we have a coefficient of this y positive and sign is greater than. If coefficient of y positive, okay, got it, first condition is true, then in greater than equal to, you just make some arrow above these red line which show the required region. But stop it here, not shade the region, because we have another constraints. Now we start with second constant, 4x plus 2y is greater than 16. First convert this into corresponding equation or associated equation, mean just convert or write this greater than equal to, simple equal to, make a table by putting x is equal to 0 in equation 2. We have y is equal to 8 and x is equal to 0. We have y, y is equal to 0. We have x is equal to 4. So just draw these two order pairs, mean at x is equal to 0, y is equal to 8. This is your 0, y is equal to 8 here. You can see on green circle, color language, follow this. X is equal to 4 and y is equal to 0. You have x is equal to 4 here and y is equal to this, and just okay. So you have another inequality named 4x plus 2y greater than 16. In order to make arrows, your coefficient of y positive, yes, positive, and sign is greater than equal to, so just make some arrow above this line. So, and the next constant is x is greater than equal to 0. X is greater than equal to 0 mean you are talking about y-axis, and y-axis positive mean right hand side. You can see on your graph paper, this is your y-axis, and greater than sign mean you have to draw some arrows right of that orange line. And lastly, we have y is equal to greater than equal to 0 mean you are talking about x-axis, and x-axis positive mean above that blue line or x-axis. So make some arrow above that x-axis. Now you should shade the region which will represent the joint region. All the arrows should be represent a direction, that is our required region. So in order to find optimal solution, first step is to find feasible region. Okay. Second step is to find corner points. Corner point is that point where two lines intersect at this shaded region. Mean you have this corner point, second and third, three corner point we have. In next slide, I am going to find these three corner points. Got it? Now we move on to our second phase. So we have corner point, you can see on diagram 6 and 0. 6 and 0, this is your first corner point. You can directly write from your graph. Second one is 0 and 8, but third corner point is a tricky one. Mean you have to find this corner point, nothing special. You just have to solve this two equation which intersect this point. The first equation, you know that I named it equation 1, and the second one equation 2. You just have to solve this simultaneously. Mean multiplying equation 1 by 2 and subtracting equation 2. So multiply equation 1 by 2 and write equation 2 and subtract this. In order to subtract this, 4x negative cancel, mean we have y is equal to 2. Just put this value of y in equation 1 or 2, mean put y is equal to 2 in equation 1, you have your value x is equal to 1. So our point of intersection of these two lines is 3 and 2, mean our last corner points are 3 is 3 and 2. So we have all our corner points 6, 0, 3, 2 and 0, 8. Second step is completed. Now I am going to complete our final and last step is just to put these corner points into our main objective function. So move on to, we have these three corner points. Just put this corner point in your objective function. I suppose this it's equation number 3. Put first point at this equation number 3, mean put x is equal to 6 and y is equal to 0 in equation 3, and simplifying this you have your answer 1, 5 and 0. Again put your second number which is 0 and 8, you have your answer 240, and lastly put order pair 3 and 2 in equation 3, you have your answer 135. You have to find minimum of this function, so we have value minimum at 0.32, which is 135, so the given function is minimum at 0.32 here. And in word problem, just convert this, mean we have to use 3 units of food x and 2 units of food y in order to feed each animal. So students, just follow these three rules, you have your answer. So this is your problem number 7. Now I am going to discuss our next word problem, which is problem number 8. And the problem is, a dealer wishes to purchase a number of fans and sewing machines. He has only 5,760 rupees to invest and has space at most for 20 items. A fan costs 360 rupees, sewing machine costs 240. His expectation to have a profit of 20 rupees for a fan and 18 rupees for a machine. You have to find the maximum profit in order to use this amount. So just convert this statement into different shape, into picture form. You have two types of product, mean fans and sewing machine, and the dealer has only 5,760 rupees, so he can use this amount or less than equal to sign. He can choose not more than 20 items. He has space at most 20 items, so at most mean less than equal to 20 items. And a fan costs 360 rupees and sewing machine costs 240 rupees. And next information is expected profit on each fan is 22 rupees and on each sewing machine is 18 rupees. You have to find the maximum function of objective. Again, suppose x denote the number of fans in your purple color and y denote number of sewing machine. So make an objective function, maximize z is equal to 22x. We have 22 rupees fan profit on each fan and 18 rupees profit on each sewing machine. So we have 22x plus 18y subject to constraint, and what are constraint? 360x plus 240y is less than equal to 5,760, mean he has only 5,760 rupees in order to purchase this. And the second condition, he has space of 20 items, mean x plus y is less than equal to 20. And the third one is x is greater than 0, and fourth one is y is greater than equal to 0. So just convert this word problem into linear inequalities, then find the optimal solution and follow the three rules. First one is to find the feasible region. So take your force inequalities. Just have a simplify this, mean just taking common 120 on left hand side, on right hand side cancel this 120, you have simple equation which is 3x plus 2y is equal to 48. Just make it simple and now make your table, mean just to convert this into associated equation. Put x is equal to 0 in equation 1, you have y is equal to 28. Put y is equal to 0 in equation 1, you have x is equal to 16. Now again, a very important thing while making a graph is scale. In this case, we take a small square is equal to 4 unit in x-axis as well as on y-axis. So make a graph. You can see on this graph, one small square box is equal to 4 unit. So first order pair, we have x is equal to 0, y is equal to 24, x is equal to 0 here and y is equal to 24 here. X is equal to 16 and y is equal to 0. X is equal to 16 on x-axis, y is equal to 0. Just make a line by passing through these 2 points. You have your inequality. In order to shade the region, first check our first condition is coefficient of y positive, yes. Then less than equal to sign mean just shade or just make some arrow below this purple line. Got it? And the second constant is x plus y is less than equal to 12. Just convert this into our associated equation. Make a table by substituting x is equal to 0 in equation 2. We have y is equal to 20 and y is equal to 0 in equation 2. We have x is equal to 20. So draw these 2 points 0 and 20. This is your point 0 and this is yellow line, a yellow circle represent this, and 20 and 0, and make a line, name the line x plus y, and the condition is your coefficient of y is 0, yes. Then you should shade the line below this, mean less than equal to, so make some arrows below this line. Okay. And the third condition is x is greater than 0, mean we are talking about y-axis. This is your y-axis and positive sign is right hand side of this y-axis. I think it's easier for you now. And lastly, we have y is greater than 0, mean we are talking about x-axis and x-axis positive is above this green line. Now, what is our visible region? Mean what is our shaded region? I think so. This is your shaded region. So, first step is completed is to make a visible region. The next step is what? To find, yes, to find corner points. So we have corner points like here, I think so, yes, 0, 0, you can see on this graph, 16 and 0, okay, directly you can write this, 0 and 20, yes, and the last one is a problem, mean you have to find this corner point. In order to find this, just solve simultaneously equation 1 and 2, mean multiply equation 2 by 3 and subtracting from 1 we have y is equal to 12. Just replaces this y in equation 2 or 1, we have x is equal to 8. So your final corner point is 8 and 12. So we have in this question we have 4 corner points. Now we move on to our next step, which is just to put this corner point into objective function. Yes, so we have objective function, say this is your equation number 3. First put your first point, which is 0, 0. So put this point in equation 3, you have z is equal to 0. Put second order pair in this equation, mean replaces x by 16, y by 0, you have 352. Then next point, put 0 and 20, we have 360. And lastly, we have 8 and 12, you have your answer 392. We have to maximize the profit. In order to maximize, you should use this order pair, mean 8 and 12. Mean you should purchase, or dealer should purchase 8 fans and 12 sewing machine in order to get his maximum profit. Got it? Simple one. And last, our problem today lecture is, it's like problem number 7. A machine can produce two types of product A, 2 units of chemicals and 1 unit of compound, and can produce product B by units 1 unit of chemical and 2 units of compound. Only 800 units of chemical and 1000 of unit compounds are available. The profit per unit of A and B are they. You have to maximize their profit. Got it? So we start with product A and B. Product A have 2 units of chemical and 1 unit of compound, and so product B have 1 unit of chemical and 2 units of compound. You can use only 800 units for chemical and 1000 units for compound. Next, price of each unit of A is, product A is rupees 30 and product B is rupees 20. You have to maximize the profit. Let's suppose X denotes the number of units for the product A and Y denotes the number of units for the product B. You have your objective function, which is you have to maximize this 30x and 20y. So subject to constant, just follow the purple color. 2x, 2 units of chemical, 1 unit of on product B, 2 units from product A, 1 unit from product B, and you can use maximum of 800 unit. So your constant is 2x plus y is less than 800, and what about compound? X plus 2y is less than equal to 1000. Simple is it? And x is greater than equal to 0 and y is greater than equal to 0. Got it? Okay. Just 800 of unit of chemical. Just convert this into red one and just convert this 100 unit into a red one. Units of compound. Chemical, we have a purple color, or in case of, okay, no, leave this. Okay, I just try. Okay, a perfect color combination, no need to change your color. Okay, now next step is to just solve this these inequalities, or to find maximum of that function. In order to find, first draw or find a feasible region, just convert this inequality in associated equation, make a table, put x is equal to 0 in equation 1, you have y is equal to 500, then y is equal to 0 in 1, you have x is equal to 1000. Then scale, yes, one small square is equal to 200 unit. You can take 100 unit, you can take one small square is equal to 400 unit. I just decide to take one small square is equal to 200 units. So make a graph. First point is x is equal to 0, y is equal to 500, this point. Second one is 1000 and 0. Second point, just make a line passing through this. We have x plus 2y is less than 0. Yes, coefficient of y is positive, sign is less than, so make some tiny arrows below this purple line. And the second constant is 2x plus y is less than 100. Make an associated equation. Put x is equal to 0 in this equation. We have 800. Put y is equal to 0 in equation 2. We have 400. So draw these two order pair, mean x is equal to 0, y is equal to 800 here, and x is equal to 400 and y is equal to this, and draw a line passing through these 2 points. We have another inequality, which is 2x plus y less than 800. Yes, coefficient of y positive, sign is less than equal to, so draw a some small arrows below this yellow line. Okay, and the third condition is, what x is greater than 0 mean you are talking about y-axis, positive mean right hand side, so make some arrows. And last thing, y is greater than equal to 0 mean you are talking about x-axis, above this you have this. And lastly, what is the common shaded region here? Yes, you can see in blue region which is our required feasible region. So first step completed, okay. And the second step is what? To find corner point of this shaded region. So we have corner point, you can see on graph paper, this is your 0, 0, second point is 400 and 0, third point is 0 and 500. The problem where here you can name these point A, B, C, D as. In this you have to find this point D. In order to find this point, use your equation 1 and 2, just solve simultaneously, mean multiplying equation 1 by 2 and subtracting from equation 2, and simplify this. You have y is equal to 400. Just put y is equal to 400 in equation 1. You have x is equal to, yes, 200. So your last corner point is 200 and 400. Second step completed for an optimal solution. And the third step is just to put all these corner point into objective function. So this is your objective function. Put your first point in this equation 3, you have z is equal to 0. Put second point in equation 3, you have z is equal to 12,000. Put third point in equation 3, you have 1,000. And put your last point in this equation, you have what? Yes, 14,000. In order to get maximum profit, you should take this order pair, mean 200 and 400, in order to maximum profit. So given function is maximum at 200 and 400, or you can say that you can use 200 units of product A and 400 of units of product B. So that's it. Inshallah, we will meet in our next lecture, which is related to again linear inequalities, but simple linear inequalities, not word problem. Okay, Allah Hafiz.